we are still on Laplace transform, right? We are still on Laplace transform. Now, in our previous class, we've been able to transform the possible functions we'll be seeing when it comes to Laplace transform, right? We did about 7 functions. We transform about 7 functions, right? So what we are saying is that those functions, when it comes to Laplace, we are implementing those functions, right? We are implementing those functions. So what it means is that you'll be given question, then how do I interpret question, or how do I approach question, right? So that's the main reason why we did all those transform. Now for today's class, you'll be taking the theorems. You'll be taking the what? Theorems. Meaning, I said it's just like differentiation and integration. You know, for our differentiation, we have the techniques of differentiation. For my integration, I have the techniques of integration, right? With all the understanding that I already have, that given this function, this becomes the transform. Given this function, this becomes the transform. Then given questions, how do I solve question? Right? How do I solve question? So that's the main reason why I need to know all these theorems. Now we have 3 terms basically. The number 1, it is called the first shift theorem. The number 1 theorem is called what? The first shift theorem. Number 2, multiplying by t raised to the power of n. Multiplying by t raised to the power of n, or you say multiplying by t. Why the last one is dividing by t? It is dividing by t. But take note that this first shift theorem, you can also call it as multiplying by exponential function. Multiplying by what? Exponential function. So we are going to see the reason why I said you can also call this as what? Multiplying by what? Exponential function. Now, to understand this, we are going to bring it back to what we know. I already know that given, say I want to transform a particular function, right? Say you want to transform f of t. You know, make transforming f of t. What do I have? I have f of x, right? What do I use to get f of x? The Laplace, taking the Laplace of f of t. I have what? F of x. Then this whole process or this result is done by semi-infinite integral, right? In the Laplace transform of f of t is equals to integral from 0 to infinity f of t multiplying what? Exponential negative st dt. What's our result? F of x, right? F of x. Then we've also seen that the Laplace transform of a, by the time we substitute a as f of t, meaning 0 to integral a multiplying negative st dt, my result becomes what? A over x, right? I've also seen that the Laplace transform of sine at, meaning integral from 0 to infinity sine at exponential negative st dt is equals to what? A over s square plus a square, right? I already have this idea, meaning the possible function, these are the what? Transform. The possible function, these are the what? Transform. That's the main reason why we need our table. We've seen the table, right? Any questions so far? So that's all we are saying now. We are referring to our table. All of this, it means we are referring to our table. So the idea here is that given this function, I've seen their transform, right? I've seen their transform. So we are also doing similar stuff here. When we say the first shift theorem, are we together? When we say the first shift theorem, what it means is that I'm finding the Laplace transform of a particular function multiplying by exponential function. Generally, what first shift theorem is saying is that I'm multiplying a particular function with an exponential function. Then what becomes the Laplace transform, or what becomes f of x, which is the Laplace transform. I get me out of just like we've seen for all of these, saying if f of t is this becomes the transform, right? Now, first shift theorem, it is telling me that I have a particular function, meaning I have any of the function we found their transform so far, but all of these functions, they are multiplying what? An exponential function. They are multiplying an exponential function. So if they are multiplying an exponential function, what becomes what? Transform. What becomes what? Transform. So I'm saying that is either you call it the first shift theorem, or you say what? Multiplying by exponential function. But mostly, or in all textbooks you'll be seeing the first shift theorem, but just have that understanding that that's what it means. All right, back to what I know. I know that the Laplace transform of f of t is equals to integral, just as we've written here, is equals to the integral from 0 to infinity, right, f of t multiplying exponential always power negative st dt. What do I have? I have what? F of x. Now in this case, when f of t is equals to exponential always power of negative a multiplying f of t. You know, I said it, first shift theorem, you are multiplying those functions that we found the transform, you are multiplying it by an exponential function. So you are taking this as reference. Say this is, you know, when I say f of t, I'm saying f of t might be a, it might be what? Sine at, it might be what? Cos at, sine at, cos at, t raised to the power of n, meaning f of t might be any of these functions. We are not saying take this as reference. Say this is f of t, meaning any of those functions. Now the exponential function, let's say this is the exponential function. You know, by exponential function, I'm having exponential raised to the power of negative 40, exponential raised to the power of what? 5t, any exponential function, right? So I'm saying that when f of t is equal to this exponential function multiplying f of t, then what is the transform? Meaning, what is the transform? Meaning what? F of x, meaning f of x. Now observe, you observe that the same way we did for this, meaning that my functions, I have my function as f of t, then I substituted into this general formula, right? So similarly, in this case, this is my what? F of t, meaning anywhere I see f of t in this general formula of integration, what do I substitute? I substitute this. The same way we found the Laplace of this function, meaning when f of t is equals to a, we only substituted the value of f of t as a, then we solve this integration, we got this, right? When f of t is equals to sine at, we only substituted f of t as this, then we solve our integral function, we got this, right? Similarly, when f of t is equals to this, meaning same idea, I'm going to substitute this whole function, say this is 1, meaning I'm going to substitute this whole function, which is 1, into the general integral function that defines Laplace. So by doing that, I have the Laplace transform of exponential always power of negative 80 multiplying f of t is equals to the integral from 0 to infinity. Substitute all of this. Wow, in this case, that's the f of t. So you're having this multiplying exponential always power of negative 80 f of t multiplying exponential always power of negative st dt, right? Moving on, I have integral from 0 to infinity f of t exponential always power of negative 80 multiplying exponential always power of negative st dt. By that we take indices, I'm having 0 to infinity f of t exponential negative s plus a multiplying t dt, meaning the Laplace transform of exponential always power of negative 80 f of t is equals to this, right? Now the question is, doing comparison, say this is 1, say this is 2, right? Say this is 1, say this is 2. Doing comparison between 1 and 2, you know, the result of 1, we are saying f of x. If 1 is f of x, then 2 will be what? Are we together? Now doing comparison between 1 and 2, from 1, the result of 1, we are saying the answer is f of x. If 1 is f of x, meaning if the result of 1 is f of x, then what will be the result of 2? What will be the result of 2? Or where do we get this f of x from? We get this f of x from the exponential, from the power of the exponential. Are you getting me? We got this f of x, meaning the transform of this function. We got it from the power of the exponential. So if that be the case, this will be what? F all into bracket s plus a. Are you getting me? F all into bracket s plus a. just observe the power of the exponential. In this case, I'm having exponential negative st. I'm taking x, right? I'm taking x. I'm neglecting t. Now, in this case too, what the power of the exponential? S plus a. Meaning, if the Laplace transform of this function is f of x, that is, the Laplace transform of this function can be written as what? F of x plus a. F of x plus a. So we are saying that the Laplace transform of f of t is equals to integral from 0 to infinity f of t exponential negative st dt is equals to what? F of x, right? Then the Laplace transform of f of t multiplying exponential always power of negative at is equals to what? Integral from 0 to infinity, right? F of t multiplying exponential always power of negative at multiplying exponential always power of negative st dt is equals to f all into bracket s plus a. So the difference here is that in this case, the power of the exponential, it is having negative st, but this I'm having negative all into bracket s plus a multiplying t. So I'm saying that this number one theorem of Laplace, you call it the first shift theorem, or what? Multiplying by exponential function, which we've seen. Multiplying by exponential function. So what this means is that, let me write this this way. So what this means is that the meaning of this is that the f of x is equals to what? F of x plus a. The difference between these two is that given a function, say you want to find the transform of a particular function, I'm going to get what? I'm going to get f of x, meaning the transform of the expected function, right? That will be seen in Laplace transform. But in this case, what is the transform of a function multiplying an exponential function? The difference is that what you've transformed, meaning the Laplace transform of a single function, the result, you are going to add the power of the exponential to the x variable. You are going to add what? The power of the exponential to the x variable. So this is what we are saying. In this case, this is the normal function, right? I got the transform as what? F of x, right? In this case, I'm having the normal function multiplied by what? Exponential function. What is the power of the exponential function? Negative at, but I'm interested in the a. So I'm saying that given a function of this nature, I'm going to get f of x first. My result, I'm going to add the power of the exponential function, which is what? A. Now let's say in this case, the power of the exponential is wt, meaning I'm going to get what? F of x, right? Me getting f of x, then my final answer for this transform, it will be what? F all into bracket s plus what? W. Are you getting me? Now let's take example. Given this question says that find the Laplace transform of this function. Now, what this question is under what theorem? This question is under what theorem? It is under the first shift theorem. Why is it under the first shift theorem? We are saying by first shift theorem, you'll be given a function f of t. That function f of t is multiplying an exponential function. It is multiplying what? An exponential function. In this case, this is my what? F of t, right? In this case, this is the what? Exponential function. Are you getting me? Now, we are not saying that following what we have here, f of x is equals to f of x plus a. Meaning, how do you solve question under first shift theorem? Your first step, first of all, find the Laplace transform of the function itself, right? Once you've gotten your answer, then the power of the exponential in the question, add it with the variable of x of that particular function you found the Laplace. Now, this is what we are saying. In this case, identify what is the f of t? Cos 3t. Now, what is the Laplace transform of cos 3t? What is the Laplace transform of cos 3t? Let's go back to our standard table of Laplace. What do I have? I have 3 all divided by s squared minus 9, right? This is correct. This is the main reason why you need to know those transform. Meaning the transform of each function, I need to know them. The transform of each function, I need to know them. Alright, so this is the Laplace transform of f of t, right? Following this, it is telling you that once you've gotten f of x, it's still the same thing as this. Meaning, identify the variable of x in this case, then add the power of the exponential. In this case, what is the power of the exponential? Negative 4. By negative 4, it means when you are adding, what do you have? Plus 4. Right? So doing that, I'm now saying the Laplace transform of exponential always power of negative 4t cos 3t becomes, I'm still writing this, right? 3 all divided by, identify your x variable, meaning x plus 4 all squared minus 9. Can you not see what we are saying? Meaning, this guy is still the same thing as this. The difference is that once you found your Laplace transform of the function itself, identify your x variable, then add the power of the exponential. If it is negative, it becomes what? Plus. If it is plus, it becomes what? Negative. So let's take another example. Let's say our question says, find the Laplace transform of exponential raised to the power of 3t multiplying t raised to the power of 2. Right? This is the question. This is our first example. This is our second example. Same idea, right? That would be what? First thing first, identify your f of t. In this case, what is my f of t? T raised to the power of 2. What is the transform of t raised to the power of 2? That's 2 factorial all divided by s cubed. By our Laplace standard table of transform, we've done all of this. So having the transform or giving a question, the question says that find the Laplace transform of t raised to the power of n. Your answer becomes t n factorial all divided by s raised to the power of n plus 1. So during comparison, in this case, what's your n? Your n is 2. Meaning we are saying that the Laplace transform of t raised to the power of 2 is equals to 2 factorial all divided by x raised to the power of 2 plus 1, which becomes what? 2 over s cubed, right? Now, by first shift theorem, we are saying that find the Laplace transform of t raised to the power of 2, and we've gotten it as this, right? Once you've gotten your answer, your next step is what? Identify the power of the exponential. Meaning, once you've identified the power of the exponential, then add it with the variable of the transform you found, which is f of t. Right? In this case, is it taking minus, is it taking negative or positive? It is taking negative. Why is it taking negative? It is taking negative because my power is positive 3t. If it was exponential negative 3t, it becomes what? Plus. So meaning from here, I'm saying the Laplace transform of t raised to the power of 2 is equals to 2 over s cubed. Therefore, the Laplace transform of exponential raised to the power of 3t multiplying this is equals to what? 2 over x minus 3 all squared. Any question? No question. No question. So can you see how it works? When we started, I said it's either you call it the first shift theorem or you call it what? Multiplying by the exponential function. So very simple. Very simple. Let's take one more. Then we move to the next theorem. Meaning multiplying by t and t raised to the power of n, and lastly dividing by t. Number three. Find the Laplace transform. Find the Laplace transform of exponential r raised to the power of negative 5t, r raised to the power of negative 5t cos 2t. What's our answer to this? Find the Laplace transform of exponential r raised to the power of negative 5 cos 2t. Solution. What's our answer, please? Same steps. First thing first, find the Laplace transform of the function, right? Which in this case, it is what? Cos 2t. By cos 2t, what is the transform? That's what? S all divided by what? S square minus 2 square, right? Minus 2 square, meaning S all divided by S square minus 4, right? If this is f of x, then f of x plus a, f of x plus a becomes what? S x plus 5 all divided by x plus 5 square, x plus 5 square minus 4. So this is the Laplace transform of this given function, meaning this is the Laplace transform of f of x. By f of x, we are saying this function. Then the given question itself, this is the Laplace transform. So this is how you go about first shift theorem. So this method or this idea works for similar question. It works for similar question. All right, let's move on to the next theorem, which is multiplying by t raised to the power of n and t